Okay, so I'm going to be explaining how I got my answers for this week's assignment. So for number one, John's score was 133 and the mean was 100 and the standard deviation was 15. We wanted to find what percentage of people scored above his score. So basically I just subtracted 100 from 133 and then divided that by the standard deviation of 15, and I found that he was 2.2 standard deviations above the mean. So that was his z-score, obviously, and then I went into the chart in the textbook for the z-scores and I found that he was 0.4861 above the mean. Then I converted that into a percentage and found and added that to 50 because that's the percentage of the mean, and I got 98.6, and then I subtracted 98.6 from 100 because you're trying to find the percentage of people that scored above his score. So then I got 1.4, and 1.4% of people score above a 133 on this particular IQ test. And then for number two, we want to find what percentage of people have scores below negative 0.5 standard deviations. And so I drew it out, and then I looked up 0.5 in the chart, and I found 0.1915, and I subtracted that from 50 because you're trying to find the amount below negative 0.5 standard deviation. So then I got 30.85, so 30.85% of people have scores below negative 0.5 standard deviations. And then for the second part, I basically did the same thing. They want to find who scored above a 0.5 standard deviation. So I found this in the on the chart in the textbook, and then I added it to 50 instead of subtracting it from 50, and I got 69.15, and then I subtracted that from 100 because 100%, and I got 30.85, which is the same as this one, but this is 30.85% of people have scores above 0.5 standard deviations. And then for number three, we wanted to see how many people, what percentage of people scored in between John and Peter's scores. And John scored a 44, Peter scored a 52, the mean was 40, and the standard deviation is 4. So I just drew it out, and I want to find in between that. So John is 1 standard deviation above the mean, and Peter is 3 standard deviations above the mean because I just used the formula where you subtract the mean from their scores and then divide it by the standard deviations. And from the charts, I found that John is 0.3413 between the mean and z, and then Peter is 0.4987. So then I added 34.13 because I converted it into a percentage and added that to the mean and found 84 and got 84.13. And I did the same thing for Peter and got 99.87. And then I just subtracted those. I subtracted Peter's I subtracted them and got 15.74, and 15.74% of people score between 44 and 52. And then for number 4, we were trying to find basically the same thing, but with Lisa and Donna. So Lisa scored a 433 and Donna scored a 549, and the mean was 500 and the standard deviation was 100. So I just kind of drew it out, and Lisa's z-score was, I did the formula again and found that her z-score was negative 0.67. And then when you look that up in the chart, it's 0.2486. And Donna's z-score was 0.49. When you look that up, it's 0.1879. And then I just added those two. I converted them to percentages and added them together and got 43.65. So 43.65% score between 433 and 549. And then for number 5, we want to find or predict Tom's score on distribution B. So, they gave us Tom's score on A, which was 204. And when you do the formula and everything, you find that his z-score is 0.16. So I multiplied 0.16 by 10 because that is a standard deviation on distribution B, and got 1.6. And then I added the 1.6 to the mean of distribution B and got 76.6. So Tom's score on distribution B would be predicted to be 76.6. And then Don's score, we want to do the opposite. So find his score on distribution A. So for distribution B, he scored a 67. So I basically just did the opposite. I did the formula and found that his z-score was negative 0.8. And then I multiplied that by the standard deviation of distribution A and got 20. And then I subtracted the 20 because it's negative. It was a negative 20. I subtracted the 20 from the mean, which was 200, and got 180. So Don's score on distribution A would be predicted to be 180. And then for number 7, they were just trying to see if Jose would be in the top 2.5%. So the mean was 150, the standard deviation was 10, and Jose's score was 164. I basically found that I did the formula and got 1.4 for his z-score, and that's converted to 0.4192. And then you add 50 to that to see that he is in he's better than, I guess, 91.92%. And then I subtracted that from 100, or I subtracted that from 100 and got 8.08%. So he's not in the top 2.5%. And I kind of already knew that because from our notes in our chart, it says right here, that for the second z-score, 97.5. So I knew that he'd have to be at the second standard deviation, but Jose did not score high enough. He would have had to get at least a 170 to be in the top 2.5% because that's the second standard deviation. And yeah,